All right, section 2.2 in chapter 2, called Functions, Relations, and Their Graphs, is called Functions and Relations. And our goal in this section is to interpret data represented in mapping diagrams. Second one, determine if a given mapping diagram represents a function. Number 3, apply the vertical line test to determine if a relation is a function. And the fourth one, determine whether a relation is a function given its graph. So a mapping diagram is basically just a diagram that looks like this. Let me try the red. Looks like this. Where instead of putting your ordered pairs and listing them out, you put them in the circles. You show a mapping. So let's just say I did 1, 2, 3, and 4, 5, and 6, and I said 1 goes to 6, 2 goes to 4, 3 goes to 5. That'd be the same as saying 1 goes to 6, 2 goes to 4, and 3 goes to 5. So the diagram shows how the function's assigning, or the relation is assigning, one input value to its output value. So given that you know the definition of a function, is this relation here in this mapping diagram, is this a function? So the question is, does every input value have exactly one output value? You can tell by the arrows. There's one arrow from 1, one line from 2, one line from 3, and one line from 4. So each input does have exactly one output, so this is a function. So let's draw a mapping diagram that wouldn't be a function. Let's do A and B. So let's think what would have to happen for that not to be a function. We would have to have, say, 1 maybe mapped to all of them. So this would not be a function because the input 1 goes to 4, and 1 goes to 5, and 1 goes to 6. So that would not be a function. All right, so if we go back to the goals, I can interpret data represented in mapping diagrams. So you're basically just going to look at the mapping diagram and say, okay, 1 goes to 6, 2 goes to 4, 3 goes to 5. Determine your input and the output that goes with it. And then the second thing was determine if it represents a function or not. So you're just looking at the mapping diagram to see if each input has one arrow going from it or not. And if not, it's not a function. All right, let's go to vertical line test. So the other goals in this section were I can apply the vertical line test to determine if a relation is a function. So let's go back here, vertical line test. And again, I do have the note sheets to go with this. So I have copies, so come see me for one if you're working on your own, and if it's in class, I will give them to you. Okay, so the vertical line test is just a method used to determine if a given graph represents a function. So here's the test. If a vertical, that's up and down like this, line is drawn anywhere on the graph and intersects more than one point the graph is not a function. So let me give a quick example. Here's our x and y axis. Here's a graph. If I draw a vertical line here, it's going to hit the graph in more than one spot. That is not a function. Okay, so the two key terms in this section are mapping diagram, and we went over what that looks like. The circles just shows how the input maps to the output, and the vertical line test to determine if a graph is a function or not. So I would like to go over the study guide in Apex. There's always a study guide, and if I'm not here, if there's not a video, you can print these out on your own and go through this and find the information in Apex by yourself. But let's see if we can do this together. So either print off the study guide now or come see me, or again, you can take notes on your own piece of paper if you don't want to do it this way. So fact, in a blank, a single input gives back exactly one output. Remember, that was a function. That was from the lesson before. In a blank, a single input gives back one or more. This is a good way to review. That's a relation. Summary. A blank, I guess we put these words in. A function is a relation that gives back exactly one output for each input. Okay, then let's review. We've been mapping diagrams. We just went over, right? Input or output are the words we're looking for. Input or output. Show how a function or relation assigns blank values to blank values. A mapping shows how a function assigns input values to output values. We just talked about that. The left side shows all possible input. The right side shows all possible output values. The arrows connect blank to their blank inputs. The arrows connect inputs to their outputs. So not hard, but it helps. Very good review. Okay. Answer each question about mapping diagrams. How can you tell when a mapping diagram shows a relation is not a function? How did we do that again? Well, we could draw a picture. I mean, if we have more than one arrow from an input, it's not a function. So let's say if there is more than one arrow from a number on the left. How can you tell when a mapping diagram does show a function? Let's say only one arrow per number, only one arrow per input. Right, how many ordered pairs can be written for each arrow? So each arrow, even though there's this arrow, each arrow is one ordered pair. So each arrow is 1. So this has the point 1, 7, 1, 8, and 1, 9. All right, number 4, draw arrows on each mapping diagram below to match its title. List the ordered pairs to the right of the diagram. So that's on this page. Okay, a relation that is a function. So we're just supposed to draw an example, and you can go ahead and do that on your own. If it is a function, I could do this, this, that. There you go. So let's list the points. My 1 went with 3, and you don't necessarily have to use all of them. 2 went with 2, 3 with 4, and 4 with 1. So that is a function. And let's do one that's not a function. Again, we could go like this. We could put 4 with 1 and 4 with 2. And then 2 goes with 3, and we don't necessarily have to have arrows at all the numbers. Typically, we have arrows. All right, so that's just a review of the mapping diagrams. Let's review the graphs, X or Y in each blank. A lot of times if you read these directions, it's not as hard as it looks. Graphs shows a function relation plotted as ordered pairs. It's always XY for an ordered pair. The blank axis usually shows the independent. Remember that from yesterday? X is the independent. And the Y shows the dependent. If all the ordered pairs have different blank values, the graph shows a function. It has to be different X values. A graph of a function never has two different points with the same what coordinate? With the same X, because you couldn't have the point 1, 2 and 1, 3. That wouldn't work. That would not be a function. Answer each question about graphs and functions. What test can you use to decide if a graph is a function? Remember the vertical line test? This is a great review. Reviews everything we just went over. And then number 2, how does this test work? The vertical line can only intersect one point on the graph to be a function. I think I have a couple examples after this. Let's see. Yeah, so write function or not a function. So vertical line test goes through 2 points, not a function for that one. Vertical line, and this is called an ellipse. They're going to ask you questions. There'll be some questions on the quiz. An ellipse is not a function. This is called a hyperbola. Hyperbola, and that will come up. Hyperbola, you can see right there, that is not a function. Look at this. There's no specific name for that, but if I do a vertical line anywhere, it's only ever going to hit in one point, wherever I draw it. So that is a function. And a parabola can be a function. If it's sideways, it's not, but this one is a function. So this one is. All right, so after all that, you're pretty set. You should be able to go on Apex now and take quiz 2.2.3. The 2.2.3 is on mappings, and 2.2.4, that's on the graphs. So you should be able to do both of those and be all set.